This is the Michelson interferometer. The goal is to create interference patterns via optical path difference and mirror tip and tilt. At the right, we have an extended mercury source. In the center, we have a beam splitter and a compensator. Over here, a mirror M1, and at the top, a second mirror M2. Light comes from the extended source, is split evenly at the beam splitter. One path goes through the beam splitter initially to M1, reflects back off the beam splitter and down to the bottom of the screen. A second path reflects off the beam splitter initially, then off of M2, passes back through the beam splitter and to the bottom of the screen. The beam splitter has some thickness to it, and the reflecting surface is on the back. The path to M2 passes through 3 thicknesses of glass, once when it initially reflects and again when it passes back through. The compensator's job is to equalize the optical path length by adding extra glass that the path to M1 has to pass through. Passes through once initially, again a second time, and then a third time when it goes back to reflect off the beam splitter. M1 has coarse adjustment here, fine adjustment at this micrometer here. M2 has tip and tilt adjustments here.
As we know from class, when we have 2-point sources, we get an interference pattern that follows these hyperbolic patterns, which when viewed from far away on this side, gives us horizontal lines. In this experiment, we have each mirror corresponds to a plane of these sources, and it gives us a plane of sources that have this hyperbolic pattern, and every level is parallel to the same level on all the other points. It gives us collimated light, which when we focus the lens gives a point, and because we have a radiosymmetric system, we get a circle pattern, which we call hinge or fringes. Second case, this is with an optical path difference and no tilt. Second case, we have no tilt and no optical path difference. M1 and M2 are going to be in the same plane, and we're going to get a single constructive fringe. The third case is when we have an optical path difference of 0 and no tilt, or and tilt. So we're going to get this hyperbolic pattern in 2 places, which again, viewed far away, gives horizontal lines. Those are going to come and give us the horizontal patterns. And when the optical path is exactly 0 and we have white light, all the wavelengths are going to line up along this axis, but then they're going to quickly get out of phase due to their wavelength differences.